Welcome back to Applied Mathematics. In this video, I wanted to talk about unit rates, which are probably one of my favorite problem-solving features. Unit rates are closely related to proportions. Thinking, for example, about a rate at which someone is typing. Right? If a person can type 285 words in 15 minutes, and we want to know the number of words that they could type in 20 minutes, we can set that up as a proportion. We can solve for our unknown x and go about our lives. But that's actually a lot messier than it might seem at first glance. Because let's imagine that we still are dealing with this person who can type 285 words in 15 minutes. And now we want to know, how long is it going to take for this person to write a 500-word essay? And we start to see that having this block, this 285 words over 15 minutes, showing up again and again in all of these equations, starts to become cumbersome. And so we take our unit rate of this. We have 285 over 15. The numerator is in units of words. The denominator is in units of minutes. And I can use a calculator to divide. 285 divided by 15 is 19. All right, so this person can type at 19 words per minute. Not exactly a speed typist, but honestly better than me. This idea of a unit rate allows us to shortcut a lot of the process of solving a proportion. You can recognize you have a unit rate because the word per appears. And if you just think about your everyday life for a couple of minutes, you should probably be able to come up with 10 or 15 examples of things that you measure where the word per shows up. Your car's rate of speed in miles per hour. The rate at which the gas station charges you for fuel in dollars per gallon. The fuel economy of your car in miles per gallon. The cost of salami at the deli in dollars per pound. The rate at which you are able to download this video in order to watch it in bits per second. Rates show up all over the place. And once you have unit rates, you can start using them as a shortcut measure for solving proportions. As with many things in mathematics, there are several ways to go about it. I'm going to explain my favorite, which is not the only way. So if you're familiar with this using different notation, there's probably nothing wrong with that. But if you've never seen this before, hopefully this makes sense. And even if you have, then maybe this will help you understand things a little bit further. All right, I don't care where it has come from anymore. I'm now in this mindset of dealing with 19 words per minute. And I know that that is 19 words over minute. Again, yeah, I know it was 285 over 15, but we've reduced the fraction. And we've found a nice way of communicating it. I can treat this as a conversion factor in order to solve problems. If I take that 19 words per minute and multiply by 20 minutes, put that over 1 so it looks like a fraction, cancel out the minutes between the numerator and denominator, and we're left with a number of words. Right? 20 times 19 comes out at something. My brain is blanking on this. 20 times 19 comes out at 380. That makes a lot more sense. Or the other problem that I had mentioned. We needed to type 500 words. Now, if I just multiplied by 19 words over a minute, that wouldn't cancel things out. But just like unit conversion factors, I can multiply by the reciprocal or divide by the conversion factor, either way you want to think about it, as minute over 19 words. In that arrangement, words cancel out. We are left with units of minutes, and my calculator is happy to tell me that 500 divided by 19 is, I'll round it and call it 26 minutes. All right. So if you have a unit rate, you can use it as a conversion factor and use all the same tricks we used for doing unit conversions early in the semester, converting between some very interesting things. On the idea of unit conversions, oftentimes we can use unit rates themselves as a way of comparing two ideas. But sometimes that's a little bit fuzzy when the units don't quite match up. For example, you might be interested in comparing the economy of purchasing a one brand or another of detergents. Maybe one of them comes in a 50-ounce bottle, and the other one comes in a 1-gallon bottle. And so we have prices of $24.85 for 1 gallon, or $17.95 for 50 ounces. I can write out a unit conversion, or a unit rate for each of these. And we have $24.85 per gallon. We have $17.95 over 50. Which my calculator is happy to tell me is $0.359 per ounce. But comparing dollars per gallon and dollars per ounce does not quite work. So we're going to need to use a unit conversion in order to get there. I'm going to take the $24.85 per gallon, and I'm going to convert that to dollars per ounce. I don't know the number of ounces in a gallon offhand, but I do know that 1 gallon is the same thing as 4 quarts. I know that 1 quart is the same thing as 4 cups. And I know that 1 cup is the same thing as 8 ounces. And by setting this conversion up carefully, gallons cancel out, quarts cancel out, cups cancel out, leaving me with ounces in the denominator, which is exactly where I want them to be. So it looks like I'll take the 2485, I'll divide by 4, I'll divide by 4 again, then I'll divide by 8, and I will get 0.194 dollars per ounce. And with this written out in this form, I think it becomes abundantly clear that purchasing the 1 gallon is going to get you a much better value than purchasing the 50-ounce container, unless, of course, the 1 gallon container is of a brand that is ineffective. But all else being equal, the 1 gallon container seems to be a better value. Probably some of you are asking the question, well, why didn't I just convert from gallons to ounces way up here? And absolutely, yes, I could have, and it would have been easier. I wanted to go through this one the hard way because I wanted to talk about taking the information about the product and turning it into a unit rate, and I also wanted to talk about doing unit conversions on unit rates. Either and both of those things are very useful and very important for being a conscious consumer, but they usually don't both show up in the same problem the way I tried to force the hand here. One last unit conversion on unit rates before I wrap up for this video. Let's think about a rate of speed. How about a rate of speed of 37 feet per second? And we're more accustomed to dealing with speeds in miles per hour, mph. Well, rewriting this, feet per second is feet divided by seconds, and then we can start multiplying in our conversion factors. I know that 1 mile is 5,280 feet. Setting it up that way, the feet will cancel each other out, leaving me with miles in the numerator, which I know I need for my miles per hour measurement. Then, if you know offhand that 1 hour is 3,600 seconds, you can do this in one go, but I'll write it out in 2 steps. I know that 1 minute is 60 seconds, and I know that 1 hour is 60 minutes. And why did I set that up like that? That's not what I need. Sorry about that. I know that 1 minute is 60 seconds, and there are 60 minutes in 1 hour. And if I set it up in that orientation, the seconds here cancel out the seconds there. The minutes here cancel out the minutes there. I'm left with hours in the denominator, which is what I know I needed. So grabbing my calculator, I have 37. Looks like I'm going to multiply by 60. I'm going to multiply by 60. I'm going to divide by 5,280. And I'm going to get 25.227, etc. I've got 2 significant digits here, so I'll just call it 25 miles per hour. All right. There's a lot that you can do with unit rates. Honestly, this video is just scratching the surface, but I hope it's giving you enough flavor that you can see why and how working with this can be beneficial. I think that's far enough for this video, so I'll wrap up here. As always, thank you for joining me, and I'll see you next time.